Okay, right. Good evening, everyone, once again. So let's continue with our oscillation waves and optics. But I think we'll really start with the revision of this. And like I said, I have already told you the topics that we're supposed to cover in this 1.5 hour of class. So we'll just get started with the same. The first topic I'm covering is spring mass block people. Spring block mass, or whatever we call it. Please give me spring block system. So without going to very fundamental stuff, you already know the formula that restoring force is given by minus kx. That's fine. There is it's not a theoretical detailed class, but I need to explain that how this exists, right? Next, where the value of k people, the value of omega is actually given by under root of k by m, and hence the value of time period eventually becomes 2 pi by omega, which becomes 2 pi under root of m by k. Frequency becomes 1 upon time period, so frequency is 1 upon 2 pi under root of k by m. People, a couple of common mistakes which students tend to do is that a common formula of time period which you have by heart is for simple pendulum, and that is 2 pi under root of l by g. You know that simple pendulum is 2 pi under root of l by g. So it may just happen that they may give you that a spring lock system has, let's say, time period of this much on Earth. What is the time period of this spring lock system on Moon? What will be the answer?
Same होगा, mass ऊपर depend करते हैं.
Exactly. People, we are talking about spring lock system. Spring lock system का time period is independent of gravity. Only for simple pendulum it depends on gravity. Remember, this formula is for simple pendulum, and this depends on gravity. So here time period is under root of 1 by g, and you can say what is gravity on Moon, by the way, in terms of what kind of artificial relationship?
1 by 6 of Earth.
Okay. So in that case, you can say time period becomes root 6 times time period of Earth. That's okay. But that is for simple pendulum. For spring lock system, it is independent of gravity. So if I have a spring, I have a block, and whatever is the time period of this spring lock system on Earth, same will be on Moon, same will be on Jupiter, same will be on any other planet or anywhere in our universe. People. Okay? So that's first important thing, independent of gravity. Okay? Second is that this k people, instead of k, you can have k effective too. If you are using 2 or more springs, block will remain one. You are not going to use multiple blocks. You will use only one block of mass m, but springs could be multiple. So in case of multiple springs, k will be replaced by k effective for multiple springs. Okay? So in that case, the time period becomes 2 pi under root of m upon k effective. Okay? Then you have got combination springs in series and springs in parallel. Okay? There were springs in series and there were springs in parallel. So obviously, when the springs are in series, how do you find k effective people if springs are in series? Suppose if I give you
X is equal to x1 plus x2.
Okay, but how is there a direct way to remember k effective formula?
1 by k1.
The reciprocal addition, not k1 plus k2. Here, when they are in series,
k1 k2 upon k1 plus k2.
Yes, k1 k2 upon k1 plus k2. That is correct. So, but remember, basically, you have by hearted for 2 springs. What if I give you more springs? So you need to remember that this is reciprocal addition. Okay. So if suppose you have got multiple springs who are in series like this, and there is a block of mass m. Okay. And let's say this is k1, this is k2, this is k3. So basically, this whole system can be replaced with an effective spring, which can give us the same result, k effective. And this k effective, it is not k1, k2, k3 people. Now reciprocal addition happens here. 1 upon k effective is 1 upon k1 plus 1 upon k2 plus 1 upon k3. Okay. There is a good derivation for this. Obviously, we are not taking that right now in this 1.5 hour class. Okay. So 1 upon k effective is 1 upon k1, 1 upon k2, 1 upon k3, and it goes on. So in series, there is reciprocal addition. And in parallel, there is direct addition. So it is similar to capacitors, you know. For capacitors also, if capacitors are in series, there is reciprocal addition. If capacitors are in parallel, then there is direct addition. But for resistors, for inductors, there you have got direct addition for series and reciprocal addition for parallel. Okay. So, and if you have got springs in parallel like this 1, 2, and maybe suppose there is another spring, but all of them are usually connected to a single block of mass m, and this is k1, this is k2, then this is k3, then k effective people, when they are in parallel, there is direct addition, k1 plus k2 plus k3. I hope this is understood. Please tell me if not. Okay. Next, proceeding ahead. So suppose if we take a random question like this. Okay. And suppose they have given us, let's say this is k, this is 2k, this is 3k, and let's say this is 6k. Okay. And they're asking you to find the frequency of oscillation of this. So first of all, these three are in parallel. So instead of them, the k effective for these three, direct addition, k plus 2k plus 3k, answer is 6k. Okay. And now we have got, instead of these three, I've got a single 6k, but there is already another 6k parallel, there is already another 6k, and then there is block of mass m. Now these are in series. Because these are in series, you have to use parallel formula people. 1 upon k effective will be 1 upon 6k plus 1 upon 6k. Okay. So this is 2 upon 6k, or I can say k effective is 3k. So my answer of frequency will be 1 upon 2 pi under root of k by m. This is k effective by m, final k effective. Okay. So 1 upon 2 pi under root of 3k by m. Okay.
Yes, sir.
Next. Proceeding ahead. Now, there's another common mistake which students have tend to do. I don't know if you're aware of this or not. Suppose if I give you this is k, if I give you this is m, if I give you this is 2k, and if I ask you what is k effective here, what is the answer? Is it series? Is it parallel? Is it inter series? Not parallel?
3k parallel, sir.
Okay, and how do you decode that this is parallel?
So
So the point is there is only one. See, whenever you have blocks connected in between, it becomes parallel. So actually, the thing is, story looks something like this. You have got one string, you have got another string, and you have got block of mass m. Right now, as you see, one edge is connected to the block, one edge is connected to the block, one edge is connected to the rigid medium, one edge is connected to the rigid medium. Same is the story here. One is to the block, one is to the block, one is to the rigid medium, one is to the rigid medium. This is parallel. And even if you don't understand it this way, you can divide this in 2 halves first of all. Does it really affect our answer right now? It doesn't. I've just divided it into halves. And now just rotate the rigid medium by 90 degrees. You will understand it better. Just rotate it by 90 degrees. Till this by 90 left, till this by 90 right, you get a same combination. Please remember they're not in series. This is parallel. Okay. And because these are in parallel, obviously you have to add them directly. In parallel, you do the direct addition. So k plus 2k, this is 3k. Good. Okay.
Understood.
Proceeding ahead. Next is cutting of springs. Are you aware of this concept? If a spring is cut, then what happens to k effective, or what happens to its k value? So suppose if I give you a spring k and it has a block of mass m, or just let's talk about spring right now. And suppose if I cut it in 2 halves, then let's say this is 1 half and this is 1 half, second half. And suppose it is cutting to equal halves right now. Initially, let's say this was L. Okay, so this becomes L by 2. This becomes L by 2. So let's say this is now K dash. This is also K dash. So what is the value of K dash in terms of K?
2K.
Okay, yes, perfect. So people, K is inversely proportional to length. Please remember. Okay, K is inversely proportional to length. There is a good derivation of this, and that derivation maybe we can cover only if you have a covered it in field. Have you learned this concept before? Yes, no?
I'm afraid no.
No. Okay, okay. So we can cover it because it takes us to elasticity, and I think it will be a good revision too. So we'll just do that. So basically, remember K is inversely proportional to length. So if length is half, first of all, K will automatically become double. So K dash will become 2K, K dash will become 2K. So good question like on this can be created here, but first please copy this. This is a fresh concept. Okay, sure. So what you can do is question can be created here that a spring of spring constant K is cut in 3 pieces in length ratio. In length ratio 1 is to 2 is to 3, which is equals to L1 is to L2 is to L3. And then the cut pieces of length L1 and L2 are connected in series, but L3 is connected to them in parallel. Okay, find the final K factor. I just created a very random question right now. Find the final K factor. Okay, let's do this. So I hope the question is understood basically. So they have given us that there is a spring. Okay, it has a value K. The length of this spring is L initially, and now we have cut this in 2 halves, 3 halves, such that one half has length L, the second half has length 2L, and the third half, no, actually not L to L. The first has, what is it? Well, the ratio is 1 is to 2 is to 3. So listen, how do we find the values? Understand L1 is basically A upon A plus B plus C into L. Okay, so ABC is the ratio basically. This is how you find the length. ABC is the ratio. So what is the ratio they have given you? 1 is to 2 is to 3. This is A is to B is to C. Okay, so this becomes 1 plus 2 plus 3L. So this becomes L by 6. So the first part is L by 6. The second part L2, that would be B upon A plus B plus C times L. Okay, so what will be the length of that? The length of that would be 2 upon 1 plus 2 plus 3. I hope you are understanding. Please tell me. See, I'm rushing obviously for this revision class. We don't have much time. But you can always tell me that, sir, please give me. So this is 2 upon 6 times L. This is 1 by 3 times L. So the second length is L by 3. The second length is L by 3, which is double. This is double. Obviously, not 2 times L by 6. It's double. Okay. And the third length that we have, that would be 3 upon 1 plus 2 plus 3 times L, which is 3 by 6 times L, and that is L by 2 people, which is triple, basically of the initial length. The length here is L by 2. Okay. So people, what will be the value of K here? 6K. Here the value of K would be 3K, and here the value of K would be 2K. Have you understood this? Tell me if not. All the 13 of you are right now. Any questions? Sure. So first, are you comfortable with this formula that how do we find the value of individual lengths?
Just please go through it again.
Sure. So basically, let's take a simple case first. Suppose if I give you one value of L and you divide it in 2 halves. One is A times L, other is B times L. Okay. What is the meaning of that? AL plus BL. This is total length L. So L1 is basically A times L and L2 is basically B times L. A and B are the coefficients. Okay. Or I can say that A plus B is basically 1. Okay. And what we can do here is we can take ratio. So AL upon AL upon A plus B. This is L1 upon 1. I'm just taking ratio. Is this fine? AL upon A plus B. This is L1 upon 1.
Yes, sir.
So that's how we find the formula. So L1 is AL upon A plus B. Similarly, what will be L2? BL upon A plus B. This will be L2. Take ratio.
Okay, sir.
Okay, BL upon A plus B, that will be L2. Similarly, if you have 3, then you have A upon A plus B plus C, B upon A plus B plus C, and then C upon A plus B plus C. Okay? If you have 4, then you can just proceed that way. So L1 is A upon A plus B plus C times L, L2 is B upon A plus B plus C times L, and L3 would be C upon A plus B plus C times L. This is also very important mass problem that we took in classical mechanics, where if I have taken questions where we had a mass, it explodes in 2 fragments of A and B. Then how did you find M1? M1 was A upon A plus B into total mass. How did you find M2? It was B upon A plus B into total mass. So we have a very identical stuff we have taken in classical mechanics. Yeah. So anyway, so we found out the individual lengths. And what is the individual length? L by 6, L by 3, and L by 2. So obviously, it is inversely proportional to spring constant of, so it is 6K, 3K, 2K. Now is this fine, everyone?
Yes, sir.
Okay. And okay, so this is L1, this is L2, and this is L3. And what we have mentioned is, now L1 and L2 are in series and L3 is in parallel. Okay, they mentioned that L1 and L2 are in series and L3 is in parallel. L1 and L2 are in series and L3 is in parallel. So what is L1? It is 6K. What is L2? It is 3K. And what is L3? L3 is 2K. And now we know what to do. So when they are in series, you have to apply the reciprocal formula. So for this, 1 upon K effective would be 1 upon 6K plus 1 upon 3K. So this is 1 upon 6K plus 2 upon 6K, which is 3 upon 6K, which is 1 upon 2K. So K effective of the series combination is 2K. And now, instead of these two, we have got a single K effective, which is 2K, and we already have 2K here. This 2K is in parallel. So the final K effective, 2K to be directly adds up 4K. Have you all understood this?
Yes, sir.
Good. So that's about writing of springs. So I think this is all that I wanted to take when it comes to spring mass oscillation system. Okay. Let me see if there's anything else. I think this is fine. And now we can take questions on small oscillations. Please give me small oscillations. Okay. So this usually deals with potential energy function, basically the equilibrium concept that you already know. It is related to equilibrium. So we'll just go through some steps. So what mostly will happen is they will give you potential energy. Okay, they will give you potential energy, U of x. Okay, and they will ask you that a particular spring block system with potential energy this much is given small oscillations, find its frequency or angular frequency. Please take care of a couple of things. If they mention frequency, it is f. If they mention angular frequency, it's omega. Many times you can also check units. If it is hertz, it's frequency. RPS, it is frequency. CPS, it is frequency. RPS is revolutions per second or rotations per second. CPS is cycles per second. All of this is frequency. Remember, RPS is not radians per second. RPS is revolutions per second, RPS is rotations per second, but it is not radians per second. Radians per second is exclusively written as RAD upon S. Radians is written as RAD, it is not written as R. Please remember. Okay. So U of X will be given to you, and after this, whichever kind of equilibrium, stable, unstable, or neutral, for all the kinds of equilibrium, du by dx is 0 at mean position. So using this, you can find the value of x naught first of all. We will use this will be given. We will use this, and we will find x naught. Once x naught is found out, then you find d square u upon dx square. Okay, you find the value of this, and then you will find it at x equals to x naught. Basically, after finding this, you will substitute x equals to x naught, and when you substitute x equals to x naught, the value that you will get, that is known as k people. And why it is known as k, again, there is a derivation for this. Not getting into it. Okay, that is nothing but the k is nothing but a string constant, a force constant, and that's it. So the frequency would be 1 upon 2 pi under root of k by m, and you know how to find the value of k. By the way, logically speaking, just one thing that actually when you say oscillations has happened, like oscillation, small oscillation, which kind of equilibrium in that? It cannot be actually all the types of equilibrium. Only one equilibrium can show oscillations. Which is that
Stable equilibrium.
stable. I know. So please remember, it has to be stable. Unstable equilibrium does not show oscillation. Neutral equilibrium does not show oscillation. So it has to be stable equilibrium, something like this. Okay, basically where potential energy is minimum. Where potential energy is minimum. It means that this d square u upon dx square, it has to be greater than 0. It has to be positive. Otherwise, it's logical. Can k be negative? K cannot be negative. K cannot be 0. String has k. K cannot be negative 2. K has to be positive. Is that clear, everyone? For minima, you know that the second derivative is greater than 0.
Yes, sir.
For maxima, when you talk about unstable equilibrium, which looks like this is unstable equilibrium. When ball is right now at rest, it is in equilibrium, but it is highly unstable. A small tilt and equilibrium will be lost. So this is where potential energy is maximum, but the value of d square u upon dx square at x equals to x naught, this value is now less than 0. This is now less than 0. Okay? And when it comes to the neutral equilibrium, it is something like this on a straight flow, But here, the value of d square u upon dx square is equal to 0. This happens at neutral equilibrium at x equals to x naught. Any questions, anyone? This also happens at x equals to x naught. Okay? Let's take a random question on this. Do you have any questions? Please ask. Okay. On equilibrium, one question can be expected, but so suppose we have been given that potential energy is given by minus a upon x upon l the whole square plus b into x upon l the whole raised to 4. They have given us that a comma b is greater than 0. Okay, and they're asking you frequency of small oscillations. If you're thinking, so why the word small oscillations is important here? Do you know the reason why the word small oscillations is important about stable equilibrium? Why the word small oscillations is important?
So x linearly force directly proportional to linear displacement.
Yes, exactly. So only then you will get f equals to minus kx for that condition. Otherwise, there is a correction term that happens. If small oscillation is, if you don't include small oscillation, then there is a correction term. Then the value of k, the value of k will not be just d square upon dx square, which we are using. It will be different. But that is not in our jam syllabus. It may be used later in just for DIFR, where they use correction term, but we don't have to worry about the correction term. Okay, so let's work on this. So first step, that is, first we find the first derivative. Okay, and this will be minus a. L square I can take outside, derivative of x square, that will be 2x, plus b, I can take L raised to 4 outside, derivative of x raised to 4, that's 4x cubed. Okay. Second step, we have to equate this thing with 0. So we have got minus a upon L square, 2x, plus b upon L raised to 4, 4x cubed. This we will equate it with 0. So we have got b upon L raised to 4, 4x cubed is equals to, so by the way, see, this is also a mistake which tentatively students do, and that is, did we take equilibrium in classical mechanics? What do I feel like? Have we taken? Surely. The thing is, a common tendency of the students is to throw this on RHS and cancel. But there is a problem in doing that. Can you tell me what is the problem if you throw this on RHS and equate?
One solution of x will be lost.
Yes, one solution of x will be lost because right now you have got a cubic equation, people. So there should be 3 roots. You have got a cubic equation, there should be 3 roots. If you take this on RHS and it will cancel, you'll get a quadratic equation and you will lose one solution. Absolutely. So the thing is, instead of taking this on RHS and cancelling, let's take common people. Okay, so that we will have all the 3 solutions. Good. So I can take 2x upon L square common. I'll be left with minus a plus 4b x square upon L square. This is 0. I hope I have taken common properly. Let me just check. 2 is taken, x is taken, L square is taken, so minus 8 is remaining. Here, since I've taken 2 common, I'll be left with
So 2.
yes. So this is 2b x square upon L square. Now it's fine. So as you see, either 2x upon L square is 0, or I have got minus a plus 2b x square upon L square is 0. So one of the solutions is x equals to 0. As you see, this solution would have been lost. This solution would have been lost if you would have cancelled both the sides. You would have got only quadratic solution. You would have got solution using this. Okay. So x square 2b x square upon L square is a, or I can say x square is a upon 2b into L square, or I can say x is plus or minus under root of a upon 2b times L. These are the remaining 2 solutions. So we have got 3 solutions now. 0, then plus or minus a upon 2b times L. Any questions, anyone?
No, sounds perfect.
So we have got x equals to 0, and we have got x equals to plus or minus under root of a upon 2b times L. Okay. Now the third step. So these are the 3 positions. We don't know out of these 3 which one is stable and which one is unstable. We don't know that. Okay. So first we will find the second derivative, d square u upon dx square. Okay. So let's do that. Where is the first derivative? Here is the first derivative. Let's differentiate this. So minus 2a upon L square outside. Derivative of x, that is 1, plus 4b upon L raised to 4 outside. Derivative of x cube, that is 3x square. Okay, so we have got d square u upon dx square. This is given by, let's write the positive term first. We have got 12b upon L square into x square minus 2a upon L square. This is d square u upon dx square. Remember, oscillation happens where people? Stable equilibrium. I repeat, oscillation happens where? Stable equilibrium. Stable equilibrium means something like this. So this is minima. So what is the condition for minima? That d square u upon dx square at the mean position must be greater than 0. So if you substitute this, or if you substitute this, only if the value is greater than 0, then that is your point. Only then that is your point of stable equilibrium. But the problem is, if you substitute 0, what are you getting? If if this is 0, writing negative, it means this is not our point. This is unstable point. Understood?
Yes,
Luckily, remember this is only a lucky thing
Yes, sir.
that even if you would have ignored this one, like if you would have cancelled and you wouldn't have found x equals to 0, this anyway becomes unstable. I would have done, because I know that this is a common mistake with students, I would have created a problem where students ignore the term by cancelling things, but that term should give you stable. I would have done that purposely. Okay? I'm a very bad paper setter that way. Okay? But that is it. I love to test people in these little things. But anyway, so the point right now here is that x equals to 0, luckily it becomes unstable, so this is useless anyway. It is an unstable point because when you substitute x equals to 0, you're getting negative value. So it means this has to be a stable point. Both of them will be stable. Why? Because it's anyway x squared, plus or minus doesn't matter. So both of them are our stable points. So d square u upon dx square at x equals to plus or minus under root of a upon 2b l. This is equal to, let's substitute 12b upon l square into x square. So square of this people. So that's a upon 2b l square. Okay. Minus 2a upon l square. Minus 2a upon l square. I hope you are with me. So l square gets cancelled. B and b gets cancelled. 2 ones are 2 6 now. So I've got 6a. Oh, something is wrong.
Sir,
L is to 4. Where is L is to 4?
12 upon L is to 4.
Actually, here, no? Yes.
Yes, sir.
Here I've got L is to 4. Okay. Yes. So this is L is to 4, right? So L is to 4. So I've got 6a upon L square minus 2a upon L square. So this becomes 4a upon L square. So this is your k, people. I told you, d square upon d square x equals to x. Now this is greater than 0. So this is a stable point, and this is the value of k. So your answer of frequency of small oscillations is 1 upon 2 pi under root of k by m. So this is 1 upon 2 pi under root of 4a upon m L square. Or you can say you can take 4 outside. 2 gets cancelled. 1 upon pi L under root of a by m. Any questions? Anyone? Have you understood frequency of small oscillations as a topic?
Yes, sir.
Yes, sir.
So this is also covered. The next suggestion was to take Doppler effect. Okay. So next, Doppler.
थोड़ा डैम्पिंग वाला कह देंगे.
Pardon?
डैम्पिंग सर. फ्री ऑसिलेशन डैम्पिंग.
Free oscillations, damping. Damped oscillations.
Yes, sir. Yes, sir.
But in damped oscillations, we have got 3 cases, like critical damping, over damping, and the third one is
Small damping.
small damping. So okay, we can take. But what exactly should we take in damp? Okay, let's hang on. Let me download my file. Okay, damped oscillations also. No worries. Give me a minute. Actually, hence I asked things earlier only so that things are ready. I know what I'm supposed to cover. Just a minute. I need to find the PDF. Oscillations, phase of optics. Okay. Achha, the net is off. Yeah. Okay, just a second. Okay. This is group phase 11, 12. Okay. 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 So in damped, let's okay. I'll just you can tell me again specific thing to be covered in this, because if I start from damped oscillation, then सबसे पहले तो we will go through the differential equation. That's the order. Pardon?
क्रिटिकल डैम्पिंग में कौन सा जाना?
Critical damping. ठीक है.
सर ये तो ग्राफ है ना क्रिटिकल डैम्पिंग का, वो वाला थोड़ा और कुछ नहीं.
Okay. ठीक है. Hang on. I think I know what you are talking about. So basically, आपने दो तरह के ग्राफ देखे होंगे. I'm sure. मतलब maybe you have learned one and maybe you have learned the second one. Because that is what I had taught to students, that how to remember which one is when correct. Maybe you would have seen one graph like this and another graph like this, and now you confused that which one is correct.
Yes, sir. This one.
Don't worry. It basically depends whether the initial function is sine or whether the initial function is cos. That's it. So for an example, if you like in your equation that you have of critical damping, what is the final equation that you guys have got? The value of x in terms of cos damping down. See what I have written here is something like this. X is but this is hang on. So I have taken this after quantum actually. So what I have used is e raised to x. आप लोगों ने sin और cos में पढ़ा होगा ये. But okay, that's also fine. So the point is, I think it goes something like this, where you have a and then you have e raised to something, and then you have sin or cos, whatever you want to write here. Then you have omega dash t plus alpha. So this alpha will decide. If alpha is 0, then it's a sin graph. If alpha is pi by 2, then it becomes a cos graph. So it's simple. If it is a sin graph, can you tell me should this be correct or should this be correct? From where will the thing start?
From
For sin it starts from 0. From in position. And for cos it starts from top. So both of them are correct for critical damping. But it depends on what is the initial condition. Okay? Books don't tell these things. Books में either उन्होंने cos use किया रहेगा or sin use किया रहेगा. So some books may have use this graph, some books may have use these graph. Both of them are correct. This is valid for if your function is sin. This is valid if your function is cos. So एक ये confusion I think आपको रहेगा. और
yes, sir. Okay.
because it's a vast topic, we have to अगर हम इसको पढ़ेंगे, then we will have to derive the differential equation, have to write the equations. The equations का use करके how I would have taught this, you would have used the Desmos in the class, and you would have plotted these things, and that is how you would have learned it. But okay, but still you can tell me if there is anything specific you want to cover in this. I don't know.
Yes, sir. हो गया इतना.
But ये main confusion था, I think so.
Yes, ग्राफ में तो प्रॉब्लम.
हाँ बस okay, ठीक है. So this is fine then. Also just a minute. Because you mentioned this. So basically, people, this one is critical damping, as you can see. Like right. Okay. Can you tell me concept इसके ऊपर आएगा? Just asking because you raised this topic. So suppose if I give you this, and suppose there is another graph, something like this. So which one is critical? Which one is over?
सर नीचे वाला ओवर है. एम्पलीट्यूड कम है नीचे में.
Sure. Okay. Now I'm confused. I think this is over and this is critical now. And then our the regular one, which is what do you call it? So Hang on. What is the third term that we use? Critical, over, and then light damping.
Light all damping.
Yes, over damping mein amplitude will be less. That you are correct. Over damping mein amplitude will be less. Then critical mein amplitude will be just sufficient, but just that oscillation nahi hoga. It won't go to the other side. Perfect. Amplitude mein it just won't go to the other side. But when it comes to the light damping case, it will go on the other side and it will start oscillating. But एक exponential decay होता है. Like light damping में we do something like this. You show the exponential decay and then you plot it. अच्छा, एक important thing. बहुत लोगों को ये लगता है that when it comes to this damping, people time period is still constant in that.
Yes, sir. Frequency बढ़ी घटेगी.
नहीं, frequency is also constant. Time period is also
Sir,
constant.
amplitude decrease होता है.
Amplitude decreases, but time period remains constant. What is the meaning of it is, see, it will be somewhat like this. You have to create equal this. Suppose this is 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, 12 seconds. Equal time taken. Okay, and this is the amplitude. Suppose if you are starting from mean position, then the graph will look like this. Okay, that's it. So amplitude, as you can see, is continuously going to decrease, but the time period will remain constant. That's important thing to realize. But when I say time period remains constant, it means that the time period in light damping remains constant. However, it is not same as that of the no damping case. So basically, when there is no damping, in ideal condition, when there is no damping, time period is just 2 pi by omega. That you know, time period is just 2 pi by omega. This is for no damping. Okay. When damping happens, and especially the light damping, then time period increases. It increases to, it becomes what? Under root of omega naught square minus b square upon 4m square. You may have learned this. See, it has increased. No? This is omega naught basically, and this is omega naught square minus b square upon 4m square. So if the denominator reduces, what happens to numerator? Numerator increases. Time period increases, but it only means that it has a greater value than no damping. But now this is constant. Now this is also constant. So this value is greater than the what do you call it? Then the no damping case. So what is the time period here? Here the time period is 4 seconds, people. So in no damping, time period would have been 3 seconds. But at 3 seconds is constant in no damping. This 4 seconds is constant in critical damping. Sorry, in light damping. So basically, if an exam asks you that initially the system was in vacuum, time period was T, and now the system is kept in a resistive medium, what happens to the time period? It increases. Understood? But if I ask you that in damped harmonic oscillation, is time period constant? Is it increasing? It is decreasing. People in damped oscillation, it is constant. But comparatively to no damping, it was increased. Are you understanding the juggling of English here?
Yes.
There is still confusion.
Yes, sir.
Okay? So no damping, whatever is the time period, 3 seconds. In light damping, it will increase to 4 seconds. But that 4 seconds remain constant. Samjha? So comparatively to no damping, it has increased, but after increasing, it remains constant throughout the light damping case. People. That's very important to realize. Okay? Good. Chalo. Next. So that was something important to be covered. Okay. Next, proceeding ahead. Doppler effect, right? Chalo. So we have Doppler. Okay, so actually, instead of using any reference, I will just teach you randomly. I personally have by heart only one case ka logic, and I use it everywhere. What is it? Simple. I remember where source and observer both are moving towards each other. Achha, listen, it doesn't matter source is on left or observer is on right. What matters is that English, source and observer are towards. Sorry. Source and observer are moving towards each other. Sorry, towards each other. Okay? And important is that English is maintained. I don't care whether you're drawing source on left or observer on left. So observer can also be on left, source can also be on right. Okay, I think I have to reduce my tone of speaking, otherwise I'll keep on coming up. Okay. So the value of f dash here becomes vf into. Actually, tell me one thing, when you are moving towards a source, what happens to frequency? Increases. Absolutely. So the best way to remember is v plus v naught upon v minus vs. Upper plus nature minus, obviously only in that case frequency increases to maximum. If both of you will move towards each other, that is the best case where the frequency will increase, when both of you are moving towards each other. So upper plus, it means numerator has become massive, nature minus, it will denominator has become least, again making the numerator very massive. This is the best possible case. Okay. Now this, if suppose they mention, so this is what I always remember. Now if they mention, if source and observer are moving away from each other, we don't care who is on left, who is on right. They have mentioned away. So for me, I always use this as reference. Then you write however you want. Okay. Sorry. So right now both are moving towards each other, and for towards you already know f dash is f into v plus v naught upon v minus vs. And here also I write f dash is f into v plus v naught upon v minus vs. As far as both are moving towards each other, people, formula doesn't change. It doesn't matter who is on left, who is on right. Now the language matters. If you say that both are moving away from each other, so source is here, observer is here, source is here, both are moving away from each other. So depends which reference you are taking. If you are keeping source on left, you keep source on left. But tell me, velocity is reversed now. This is velocity of source. Since it is reversed, vs will become minus vs. Simple. Vs will become minus vs. This one. Okay. So here you have minus vs will become plus vs. Have you understood this first of all? Why? Because the direction is reversed. So minus vs becomes plus vs. Similarly, when it comes to observer, observer was going on the left. Now the observer is going on the right. So plus vo will become minus vo. I know you have bihearted this very simply. You may have bihearted this as, sir, both are moving away, open minus nature plus. But I'm teaching this with a fresh perspective for one important reason that you learn in the next slide. People. What you need to remember is to remember either case, either this case or this case. Like either you keep source on left or you keep observer on left, but you will use that notation throughout. So here also, you could have used f dash as f into v and v. Again, observer direction is reversed and observer direction is reversed. So plus vo will become minus vo. Source direction is reversed. So minus vs will become plus vs. Now suppose in exam they would have asked you. So basically, when both are moving away from each other, open minus nature plus. When both are moving away from each other, open minus nature plus. Doesn't matter who is on left, who is on right. Doesn't matter. Next, important kind of questions are, well, suppose they may give you sources chasing the observer. These are tricky questions. Sources chasing the observer. Okay, but they may have given you diagrams like this, Like suppose they may have given you that there is a policeman here with an alarm siren. This is a policeman siren. Okay, and let's say there is a thief which is riding in this direction. So this is observer. This is observer, and this is source now because this is siren. Siren becomes the source. Clear? Now they have given a source on the right and observer on the left. Usually students are comfortable with source on the left. It's okay. Listen. First, you will draw your reference. What is the reference? You know source and observer moving towards each other. What is the formula for towards each other? F dash is F into V plus VO upon V minus VS. This is for towards each other. But you have to keep source on left because they have given you source on left and observer on right. This was when both of them were moving towards each other. Now tell me one thing. In the problem that I have given you, here, F dash is F into V, whose direction is same and whose direction is reverse as per our reference?
Observer.
Source has same people. Source is still on left. है ना? Source is still on left. So minus VS will remain as it is. But observer का is reversed. Here observer was on the left. Now observer. So here observer was on the right. Now observer is on the left. So plus VO will become minus VO. So when source is chasing observer, doesn't matter whether things are going on the left. Doesn't matter whether things are going on the right. Formula will remain this. But just that you need to take care that if they have given you sources on the right, while drawing your diagram, you will also draw source on the right. This is the reference you will have to take. But formula will not change. Even if suppose I would have given you the other way around now. Suppose I would have given you that here is the police siren now. So this is source. Okay. So this is source. And here is the thief moving in some bike. Okay. So this becomes observer. Even though now again the source is still chasing the observer. But in that case, you will change your reference. Now you have to write source here. Now you have to write observer here. Both are moving towards each other. You know the formula F dash is F into V plus VO upon V minus VS. So in the problem that they have given us, F dash will be F into whose direction is changed. Obviously, source is again same now. Source is again same. So minus VS will remain as it is. But observer, here it was left. Here the observer is on the right. So plus VO will become minus VO. As you see, people formula is not changed. Look at this. V minus VO upon V minus VS. V minus VO upon V minus VS. Formula doesn't change. English is important. If source chases the observer, both is minus. Both are minus. And obviously, if observer will chase the source, then both are plus. Is this understood?
Yes, sir.
Any questions? Okay. So we can take, for an example, you can take observer chases the source. Maybe you can draw however you want to draw. Suppose I'm giving you observer is here. I'm giving you source is here. Now observer is chasing the source. O and VS. You don't remember the formula, suppose. So draw the formula which you remember. Source and observer. You will keep source here, you will keep observer here. Okay. Moving towards each other. You know what is the formula for towards each other? It's V plus VO upon V minus VS. Now, respectively, you have to create an identical formula. Observer direction is same, so V plus VO will not change. But source is reversed. So V minus VS will become V plus VS. Like I said, the observer will chase the source, both becomes plus V. Okay. So that's how you can remember the formula of Doppler effect. Numericals on this should be now easy to go, but I can take a couple of numericals here. Wait, I have a PDF. I can take that. Give me a minute. This comes under waves and optics, right? Doppler. Okay. Downloads. Okay, I'm not able to find the PDF. Leave it. I'll just write the question very quickly. Or I'll just write the important facts in the question. So they have given us a stationary source. Source is stationary. Produces a note of frequency 350 Hz. Produces. It means original. Original frequency. Okay. So they have given us original frequency is how much? 350 Hz. An observer in car is moving towards the source. So car towards source. Okay. So basically observer towards source. They have given us measures of frequency. Apparent F dash measures. Measures of frequency. F dash is 370 Hz. Okay. Find the speed of the car. That is the first part of the question. People speed of car, but speed of observer. Speed of observer. That's the speed of car. No, observer is inside the car. So first of all, it's a towards case. It's a towards case. So we know F dash is F into V plus VO upon V minus VS. Substitute. So 370 is equals to 350 into V plus VO. So V is speed of sound. What is speed of sound in general? They have given us, but still have you calculated one of the speed of sound at normal temperature?
340.
Yes, you will take it to be 340 if they have not mentioned. 332 is also fine, but take 340. These are two popular numbers that you can take. Okay? So 340 is the usual value of sound in air. Okay. You can also remember speed of sound in water, 1550 meters per second, and speed of sound in air is 340 meters per second. Okay, this is air, this is water. These are two popular values. Okay, so 340 observer, you want to find 340 source. They have given it's at rest. Okay, so it's easy calculations. Remember 37 upon 35. Okay, into 340. This is 340 plus VO. Let's calculate this quickly, please. So we have VO. Calculator. We have got 37 divided by 35 into 340. That's 359.42 minus 340. You will throw this one as so minus 340. Remember 19.42. So this is the speed of car people, 19.42 meters per second, which is actually too fast. Okay, but that's fine. So 19.42. Next. Now same question is continued. Same question is continued. What will be the frequency of sound? Now in the second case, okay, case 2. So what will be the frequency of sound as measured by the observer? So F dash in the second case they are asking. If the car moves away, now the car is moving away, people. If the car moves away with the same speed, so speed you have found out. What is the speed of the car? 19.42. So if the car moves away with the same speed which you found out in the first case, what is the frequency? So F dash is F into what happens in away, upper minus, nature plus. Towards was upper plus, nature minus. So this is V minus upon V naught upon V plus Vs. So we have got F, which is original frequency, which is 350, into 340 minus observer, which is 19.42, upon 340 plus source, which is 0. Whatever is the answer. Any questions on this?
No, sir.
Next. Let's take another question. Proceeding ahead. They have given us a man stands at the midpoint of a line joining two sources. So there is source A, there is source B, and there is a man standing at the midpoint of the two lines. So equally divided, midpoint of the two lines, which produces nodes of frequencies 660 hertz and 596 hertz respectively. 660 hertz here and 596 hertz here. Now the source B and the man starts moving away from source A with a speed of 30 meters per second. So B is also moving with a speed of 30 meters per second. First of all, before this, what is the beat speed?
Difference in
New to
frequency.
my
Difference. Okay? So right now, obviously, since everybody right now initially all of them are at rest. If all are at rest, then what happens? F dash is whichever formula you use. Okay, whichever you use minus minus formula, you use plus minus formula, doesn't matter. Like plus minus or minus plus, if source is at rest, observer is at rest, 0 0. B or B also gets cancelled. Frequency will become equal. Apparent and original becomes equal if everybody are at rest. So obviously, right now, whatever is the emitted, same will be heard. Okay, whatever is the emitted, same will be heard. So beats will be the difference between them, which is 660 minus 596, which is 64 hertz. That's right now. In the first case, suppose when they were not moved. But now we have an additional case. So what is the additional case? The case is now the source B and the man starts moving away from the source A with a speed of 30 meters per second. So B is moving with a speed of 30. Man is also moving with a speed of 30. And now we have to find the value of beats. And they've given us velocity of sound is 330 meters per second. Okay? Options are also there. 2, 3, 4, 5. Sure. Okay, first of all, we will take one case individually. Let's take this case. Okay. So away wala case, observer is moving away from the source. This is source and this is observer. So observer is moving away from the source. So in the first case, case 1, F dash is away में क्या होता है people? ऊपर minus, नीचे plus. Okay. So F originally 660, V is 330. Observer is moving with 30. Observer is moving with 30. V is 330. Source is at rest. Source is at rest. So what do we have? 660 upon 330, that is 2. 2 into 300, this is 600 hertz. Case 2. Case 2. People, both of them are moving with speed of 30. क्या होगा? What will happen? Two objects. Both of them are moving with same speed. Same frequency, because both are moving with same speed along same direction. It's not they are moving towards. Both are they're moving like this. Frequency will not change because there is no relative velocity. Since there is no relative velocity, there is no point in calculating. If you want, you can calculate, but there is no point in calculating. So in this particular case, F dash will remain F. So it will remain 596. What is beats? 600 minus 596, 4. Clear, everyone?
Yes, sir.
So that's about Doppler. Doppler is also done. Okay. What is the other thing that I had planned? A real depth apparent that somebody had said. So let's take that. That is optics. Okay. I need to drink water. The revision class requires so much of energy than regular class. I think regular class also, our energy is same, the rate of speed was very relaxing. Chalo, next. Proceeding ahead. Now we are jumping to optics, apparent and real depth. Okay, first of all, let's directly take a case. So suppose I have got, let's say this is water, let's say this is air. Suppose somewhere here I have got fish, okay, and observer is outside. Whoever is the observer, we don't know. It could be any bird or it could be a human or a fisherman or whatever it is. Fisherman or human, but whatever. So take it. So since observers are outside, this is our source. Okay. Remember that fish, since it's a source, it emits light in all directions. Okay. So one light will go normal and it will go undeviated. Another light will go like this, but you are going from denser medium to rarer medium, water to air. So the ray is supposed to go straight, but it will not go straight because you are going from denser to rarer. So how does it bend people? Away from normal. So instead of going straight, it is not going to bend towards normal. What it will do is it will bend away from normal. Okay. Similarly, so the point is, if suppose a fisherman is right now standing here, okay, so ray is going to come like this for the fisherman. So for the fisherman, where is the image people? Remember, image is intersection. Image is intersection of refracted rays. I repeat, image is intersection of refracted rays. So this is refracted ray R1, this is refracted ray R2. So where these two refracted rays are going to intersect. Technically, they are intersecting nowhere. But if you retrace them back, they will intersect somewhere. Retrace this back. Retrace this back now. See, I'll retrace this one refracted ray back. Okay, and I'll retrace this one refracted ray back. People, what do you see? They intersect here. So this is where the image will be formed. So since this is where the image will be formed, this is the apparent position of the image of the fish. Okay, but what was the real position? This is the real position, and hence people fishermen are always told if you are looking at the fish, then remember that is actually a raised height. Instead of throwing arrow like that, just tilt a bit down and then throw the arrow. Because what will happen if the fisherman would have thrown the arrow like this, people, it wouldn't have collided the fish because really fish is here. So they're supposed to actually, even if they look at the fish here, they're supposed to throw arrow like this so that it hits the fish. But anyway, right now this is the apparent depth, people. This is a real depth. It's clear that apparent depth is lesser than real depth. Any doubts, anyone? All good?
Yes, sir.
Okay. Next. So what is refractive index? Refractive index of second medium upon refractive index of first medium. This is sign of incidence angle upon sign of refractive angle. Second medium is air. First medium is water. Okay. Sign of incident angle. So incident angle is this. Okay. So I can say incident angle is also this. Refractive angle is this. Okay. So I can say refractive angle is also this. Z angle. But listen, people, this is incident angle now. Incident ray, and this is normal. So since this is incident angle, this is also incident Z angle. Okay. Okay. Tell me one thing. So if you calculate, sorry, if this angle of incidence is very small, then sin I becomes I. If angle of incidence is very small, then sin I will become I. So this sin I will become I, and this sin R will also become R people. Okay. Also, tan I also becomes I, and tan I also becomes R. So can I say that? Like if angle of incidence is small, then sin I becomes I, tan I also becomes I. So can I say sin I and tan I will be approximately equal if angle of incidence is small? Okay. Similarly, I hope you remember cos I would be actually 1. We have done this thing in classical methods when angle is very small. So if I is small, which will be a condition always, okay, and if R is small, if I is small, R is automatically small by the way. But anyway, so sin I becomes I, sin I becomes tan I, and similarly, sin R becomes tan R. I hope you are with me. All good?
Yes.
So sin I can replace with tan I, sin R can replace with tan R. Now tell me one thing, what is sin I in this triangle? Opposite upon, sorry, what is tan I just opposite upon adjacent. So opposite is, let's say, x. What is adjacent? Adjacent is the real depth. Any doubts? Adjacent is the real depth. So opposite upon adjacent, which is real depth, divided by tan r people. Now listen, this is a refracted angle. So this will be refracted angle, corresponding angle, two transversal, two parallel lines, one transversal. This is also corresponding angles. What is tan r people? Opposite upon adjacent. That's x upon what is adjacent? Apparent. X upon apparent. So what do we have? Mu a upon mu w. This is x upon r into a upon x. X gets cancelled. Therefore a by r people. So we have got refractive index of n upon refractive index of water is apparent depth upon real depth. Is that clear? Any doubts? Anyone? So you can also say that refractive index of second medium upon refractive index of first medium. This is apparent upon real. Okay? Or however you do, I personally prefer it to remember it this way. Let's take a shortcut trick. Shortcut trick. Because if this gets confusing, if you forget, sir, apparent was in the numerator, or like real was in the denominator, or whatever. See in the diagram, if you know that if real is greater than apparent, okay, it means if you're writing, let's say air upon water. Tell me one thing: should this be real upon apparent or apparent upon water? Sorry, apparent upon real. Whose refractive index is greater here? Air or water? Air or water? Whose refractive index is greater?
Water.
Water, no, 1.33, and air is 1. So obviously it has to be apparent upon real. Q, because real is greater than apparent. So water is greater than air. How can this be equal to real upon apparent? This would be insane, because water is greater than air. So how can it be like apparent is smaller, and that will be the ratio would be reversed, correct? If you write real upon apparent. Only if you write apparent upon real, this makes sense because this is smaller upon greater, and now this is smaller upon greater. So a shortcut trick could be like this to remember. But anyway, this is how we can remember. Mu upon mu w is a upon r. Any questions? I'll go back to the diagram. Tell me here if you have any questions. First of all.
No, sir.
Sure, everyone? Okay. Next. So we have got mu upon mu w, which is apparent upon real. That's done. And we can take a question here. Something like this. Listen. So it's like if fisherman is observing the bird, I repeat, if fisherman is observing the bird, then bird height will be raised above. So apparent that will be smaller. I said this is a day-to-day like a common experience. Bathroom mein tum sab jate ho. You when you have that balti people, like your drum. In that drum, if you fill the water, and then if you take a jug or mugga, whatever you call it, if you keep that jug or mugga in the pani, what happens in that water? Have you seen that the size of the mugga that reduces? It contracts.
Yes, sir.
Hello. Apparent that decreases. Real that was larger, and apparent that has become contracted. This is a common experience. But the point is, only if you're observing from outside, from rarer if you're observing, then apparent is smaller than real. So obviously, if you observe from denser, what will happen? Apparent will be greater than real. Write it in English if you want. If you observe from rarer, apparent will be smaller than real. Write it. If we observe from rarer to denser, then obviously it's a common experience. Apparent will be smaller than real. But if we observe from denser to rarer, then real will be greater than apparent. Then real height will be greater than the apparent height. Sorry, then real will be less than apparent.
उल्टा कर दिया.
उल्टा करके और उल्टा कर दिया. Okay. Yes, real is less than apparent. Okay. So let's take a question where I think you'll understand this concept nicely. So they have given us a surface. Okay. There is a fish here. There is a bird here. Distance between bird and fish, bird and surface is 72. Surface and fish is 36. N2 is 1. N1 is 4/3, which obviously you know. Okay. And we want to find question. Apparent distance of fish from surface by bird. Apparent distance of fish from surface as observed by bird. बहुत सारा इंग्लिश है यहाँ पर, okay? As observed by bird. This is the first task. Second task is apparent distance of bird from surface as observed by fish. Okay, okay. So first of all, we will take the thing with which we are more comfortable with. We already know that refractive index of second upon refractive index of first, it is actually apparent upon real. We already know this formula. Okay? Second upon first equals apparent upon real. So if you take bird as an observer, fish becomes source. Listen, because it's very important. ये N2 और ये N1 है ना confusing हो सकता है. Why? People in this 2 means what? Second medium, the refracted medium, and 1 means what? Incident medium, the first medium. So here, this N2 and this N1 could be confusing because they may write N2 here, but what if this is a source? They may write N1 here, but what if this is observer? Okay, so just to avoid confusion, what we will do is we will write second or first, or we can maybe write your refractive index of the observer. Second is observer upon refractive index of source. That is apparent upon real. How about remembering it like this? It is better now. Best observer upon source, because second will be observer and first is source. That is the meaning of apparent upon real. Clear? So let's take the first case. We will remember it this way. So when bird is observer and fish is source, okay? Because the first case is as observed by bird. Who is the observer people? Bird is the observer. Okay, bird is observer. Okay, and who is source? Fish is source. Bird कहाँ पर है people? Air या पानी? Air. Refractive index of observer would be 1. Fish कहाँ पर है? Air या पानी? पानी. Refractive index would be 4/3. खत्म. कितना easy हो गया to remember it this way. So 1 upon 4/3 would be apparent upon real. Now listen. So this is what? Real distance of what? Real distance of source. Like the object that you're observing. You know? What is the real distance of object people? 36. You're observing fish. What is the real distance of fish? 36. Any doubts? Anyone? Please ask me right now. All good?
Yes, sir.
Okay. So this is 3/4 into 36. This is apparent. So what is apparent? 4 1s are 4, 9s are 9, 3s are 27, 27 meters. Don't you think this is logical? It is logical because we know अगर हम बाहर से fish को देखेंगे, it is 36, but I'm observing fish at 27 meters, which is logical. We know this is going to happen. Okay, you're observing fish at 27. So apparent distance of fish from surface as observed by bird. Now listen, they are asking you distance of fish from surface. Distance of fish from surface. So right now fish is here, people. This is very important in English. This is the image of the fish, which is at a distance of 27. Okay. So and here is the surface. Here is the surface. This is the apparent distance of fish from surface as observed by bird. Man, this doesn't make sense. Just a minute. So answer is 27 then. From surface doesn't make sense. See, these are the questions I randomly had created. Okay? So from surface it is 27. I'll just write apparent distance of fish. Apparent distance of fish as of from bird. I want to add this from bird. Apparent distance of fish from bird as observed by bird. So what is the distance of bird and surface? It's 72. So what is the apparent distance of fish as observed by bird people? 72 plus 27. Answer is 99. Is this understood? Tell me if not, please. Okay, this is the apparent position. 27 from surface, but bird is here. Bird is here people. So bird के लिए कितना distance है? 72 from the surface and 27 from the water. So bird के लिए fish is at a distance of 27 plus 72, which is 99. Any doubts?
No, sir.
ठीक है, आगे बढ़े. Next, let's take the second case. Okay, apparent distance of bird from surface as observed by fish. So now who is the observer? Observed by fish. Observer is fish people. Who is the source? Whom are you observing? Bird. Source is bird people. Okay. So fish कहाँ पर है? Air या पानी? पानी. So 4/3. Source कहाँ पर? Bird कहाँ पर है? Air या पानी? Air. So source is 1 people. Now source is 1. So mu O upon mu S, it is apparent upon real. But now observer is 4/3 and source is 1. People initially observer was 1 and source was 4/3. Now observer is 4/3 and source is 1. Because obviously now fish is the observer and now bird is the source. Fish is observing the bird. So 4/3 upon 1. This is apparent upon real. So 4/3 into real. This is apparent. So apparent is 4/3 into. So what is the real distance of the bird people? Real distance of the bird. It is 72. Real distance of the bird is 72. So 3 ones are 3, 24s are 24 into 4. That's 96. Apparent distance of the bird from the surface is 96 people. See, initially bird is here at a distance of 72. Okay, fish is here at a distance of 36. Okay, now fish is observing the bird. Apparent won't be smaller. Now apparent will be larger. It's the other way around. So where will the fish see the bird? Fish will think that the bird is somewhere here. It will be larger this side. It won't be smaller this side. It's the other way around. Obviously you got that. Right? You got how much? 10. You found out 10. Right? Sorry, 96. Found out 96. Okay, so what is the distance of this bird from the fish people? 96 plus 36. What is the answer? 132. Clear? Have you understood this? Real apparent.
Yes, sir.
ठीक है. I think ज़्यादा heavy हो रहा है तुम लोगों के लिए. Should we stop here?
सर वन क्वेश्चन.
हाँ पूछो.
सर यदि वो जैसे कॉन्वेक्स लेंस होता है उसके यदि मतलब बीच से कट कर दें.
Right. Okay.
तो सर मतलब क्या चेंज हो जाएगा?
Sure, ठीक है. So देखो दो तरह की कटिंग होते हैं. So we have got, let's talk about let's say we have got this equiconvex lens. Equiconvex. I will take both the cases. So let's take one case at a time. So if you cut it like this, okay, vertically, then we are getting a plane of convex. So obviously, क्या change होगा? Focal length. Focal length changes. Okay, but okay, focal length changes. So focal length change होगा तो क्या change होगा? और image position change हो जाएगा. Image का height change हो जाएगा. Everything changes with respect to image. ठीक है? But intensity will not change. Intensity will not change. Amplitude will not change. क्यों? Because amount of light which is going to be refracted, वो थोड़ी change हो रहा है. जितना light पहले reflect हो रहा था, है ना? उतना light अभी भी reflect होने वाला है. Okay, so intensity will not change. Amplitude will not change. You can like intensity will not change. Amplitude will not change. Intensity is directly proportional to amplitude square. But focal length changes. So the focal length change होगा, obviously image position change होगा, image का height change होगा. Okay, and how to find the change in focal length? You remember length speaker formula?
Yes, sir.
1 upon f is mu minus 1 into 1 upon r1 minus 1 upon r2. Okay, so for equiconvex lens, it is mu minus 1 into, now this is first surface, this is second surface. So this is plus r, right में जा रहा है, and this is minus r, left में जा रहा है. Second surface left में जा रहा है. Please take care people. Okay, so it's minus r. First surface right में जा रहा है. So this is plus r. Okay, so r1 is plus r, but second surface left में जा रहा है, so it's minus r. Okay, so this is mu minus 1 into 1 upon r plus 1 upon r, which is 2 upon r. So this is 1 upon f, or I can say focal length equiconvex का कितना है? R upon 2 into minus 1. This is focal length of equiconvex. Any doubts?
No, sir.
ठीक है, but focal length of plane of convex कैसा दिखता है? So listen. So now,
सर वो भी बन जाएगा. एक r एक infinite हो जाएगा.
yes, this will be plus r. The first one is plus r, and the second one is infinity, because obviously it's plane. So 1 upon f of plane of convex. This is mu minus 1 into 1 upon r1, which is plus r, minus 1 upon r2. That's infinity. So this is mu minus 1 upon r. This is 1 upon focal length. So focal length of plane of convex is r upon mu minus 1. So what we can do is, यहाँ पर कितना था? R upon 2 into mu minus 1. यहाँ पर कितना है? R upon mu minus 1. Let's multiply and divide by 2. अब ये किसका वैल्यू है? Original focal length. So focal length of plane of convex is twice the focal length of equiconvex. Clear?
Yes, sir.
हाँ. But अगर आपने इसको vertically cut किया होता, sorry, horizontally cut किया होता, if you cut it like this, then tell me one thing. क्या curvature change हुआ है? R1 change हुआ? नहीं ना?
सर फोकल लेंथ सेम रहेगी.
नहीं ना? हाँ. So R1 and R2 are not changing. So focal length same. मतलब image position same. मतलब image height same. You know, it is as good as मान लो आपके पास मिरर है, आपने इसको ना ब्लैक कलर से कोट कर दिया, लेंस से ब्लैक कलर से कोट कर दिया. It means lens will still function same. इमेज सेम जगह होगा. फर्क क्या होगा? इंटेंसिटी will be reduced. क्योंकि पहले सारी की सारी लाइट इमेज बना रही थी.
ये सर अब हाफ हो
हाँ,
जाएगा.
अभी देखो इमेज बनेगा सेम जगह पर, इमेज बनेगा सेम जगह पर, but just that now it will not be formed. I mean, the lower half will not be able to form the image. Image will be formed at the same position, but the intensity will reduce. So intensity will change and amplitude will change. Clear?
Yes, sir.
Okay. Anything else, people? All good?
सर डाउट है
पूछो.
सर रिलेटिविटी का सिर्फ डायरेक्शन बता दीजिए सर.
अच्छा, relativity ठीक है. डायरेक्शन मतलब किसका? Like in which?
ये सर क्वेश्चन बोल रहा हूं. An observer sees two spaceships flying apart with
An observer
sees two spaceships flying apart with 0.99 c.
Okay, wait. An observer is inside a spaceship. नहीं,
ऐसा कुछ नहीं दिया है सर.
an observer sees a spaceship.
हाँ, an observer sees two spaceships
Two spaceships.
flying apart. हाँ,
हाँ.
flying apart with speed 0.99 c.
Both of them are 0.99 c.
Yes sir.
And towards
नहीं सर वो दिया है कि sees हाँ वो apart दिया है सर apart. अबे
अच्छा अभी बट बोथ ऑफ देम आर मूविंग विद व्हाट स्पीड? व्हाट इज दिस दोनों का सेम स्पीड है?
यस सर, मतलब वो दिया है कि एन ऑब्जर्वर सी से टू स्पेसिस फ्लाइंग पेपर विद स्पीड 0.99 c.
अच्छा फ्लाइंग
The
अपार्ट
speed
फ्रॉम
of the
ईच
one
अदर रहेगा.
space.
ओके ओके ओके, तो एक ए रहेगा और एक बी रहेगा. वेलोसिटी ऑफ बी विद रिस्पेक्ट टू ए दिया होगा, समथिंग लाइक दैट. वी ए भी दिया होगा 0.99 c. रिलेटिव वेलोसिटी बिटवीन दिया
ये
होगा.
सर यही तो. हाँ हाँ.
हां फिर
The speed of the spaceship is viewed by the other is
speed of the spaceship as viewed by the other is.
what?
नहीं
Other is.
I'm not able to understand the question. But देखो वेलोसिटी
नहीं
ऑफ
सर,
ए
मैंने
बी.
भी कंफ्यूज हो रहा है.
नहीं नहीं मुझे लैंग्वेज नहीं समझ रहा है. बट वेलोसिटी ऑफ ए बी इज गिवन बाय वी ए माइनस वी बी अपॉन 1 माइनस वी ए बी बी द होल अपॉन c स्क्वायर. अच्छा टेल मी वन थिंग, इन योर कन्वेंशन आपने माइनस पढ़ा है प्लस पढ़ा है?
सर माइनस पढ़ा है.
दोनों माइनस
ये
पढ़ा
पढ़ा है.
है. हाँ ये माइनस
ये सर.
ओके ओके
ये भी हाँ, ये डेलस्टेड सर.
ठीक है. एंड ओके so this is velocity of a with respect to b actually. So this is what they are asking. But you are saying that an observer sees a and b flying apart from each other, है ना?
हाँ yes sir.
At a speed of 0.99 c.
Yes sir.
Okay, so it has to be मतलब ba minus vb, मतलब velocity of a with respect to ground minus velocity of b with respect to ground. So this will be 0.99 c. But we don't have information of this in that case. Something is missing in the question. बस 0.99 c है ना, और कुछ भी नहीं
मेरे
है.
को लग रहा है कि नहीं सर.
हाँ नहीं, something is missing in the question. Because we have three unknowns, so we must need two data. एक data के basis पे how can we solve this question? No, something is missing.
सर मैंने सॉल्यूशन देखा तो उसने ना दोनों को मतलब बीए भी 0.99 सी लिया है, बीबी भी 0.99 सी लिया है.
But in that case तो क्या कह रहा हूँ? So ये कैंसिल हो जाएगा.
नहीं सर, मतलब वो ऑपोजिट होगा ना डायरेक्शन, तो प्लस होगा.
No, both are moving. So that's what I'm saying. What is the convention you guys have learned? I'm talking about your convention. Wait, hang on. I will just check something here. Just a second. नहीं, but again, अच्छा you're saying दोनों को 0.99 सी लिया है.
यस सर, यस सर.
But क्वेश्चन में ऐसा लिखा है ना that A and B are moving apart from each other with a speed of 0.99 and this is what observer is observing.
यस सर.
नहीं, इंग्लिश गलत है. क्वेश्चन का इंग्लिश गलत है. Like apart from as per क्वेश्चन का इंग्लिश गलत है. Like they should write it very clearly that A is also having a speed of 0.99 and B is also having a speed of 0.99. गलत है. ठीक है? चलो. और कुछ people.
सर और एक टेक्निकल प्रॉब्लम है सर.
हाँ.
मेरा वो एडोन तो आपका जो नोट सेशन है ना, नोट जहाँ मिलता है मतलब आपका स्टोर करते हैं, वो खुल नहीं रहा है, वो क्लाइंट एरर दिखा रहा है.
अच्छा ओके, सो आई तो डोंट नो अबाउट इट, बट वी हैव लाइफ सपोर्ट सिस्टम राइट नाउ. आर दे देयर? नो दे आर नॉट देयर राइट नाउ. सो विल हैव टू टॉक टू देम ओनली. मतलब पहले बोलते ना, दे आर यूजुअली until 8:30, so I would have टॉक.
नहीं सर, मैंने उनको कल से मैसेज किया है, जो नंबर भी आ रहा है वो स्विच ऑफ है, और मैसेज भी किया था व्हाट्सएप में.
अच्छा
तो रिप्लाई नहीं आया.
ओके, आई जस्ट टॉक टू समबडी इमीडिएटली. और मैं आपका नाम है आदित्य पंडा. बट देयर विल बी कपल ऑफ आदित्य. आपका सैंडल क्या है?
आदित्य पंडा.
पंडा.
यस सर.
हां ओके, आई विल टेल हिम.
आदित्य पंडा.
हां, सो आई जस्ट ओके, कैन यू राइट योर सैंडल इन द चैट बॉक्स? जस्ट टू
PANDA.
अच्छा पंडा. ओके, पंडा.
Yes,
आदित्य पंडा. ठीक है, आई विल टेल हिम टू कोऑर्डिनेट विद यू इमीडिएटली. आपको कॉल आ जाएगा. ठीक है?
ओके सर.
ओके, एनीथिंग एल्स?
थैंक यू सर.
ओके चलो, ऑल द वेरी बेस्ट पीपल. एंड मैं ज्यादा कुछ स्पीच नहीं दूंगा, बस इतना याद रखना मैंने आपको जो लास्ट क्लास में बोला था, हैव अ गुड स्लीप टुमारो. सब बस एक इंपॉर्टेंट चीज याद रखना, कल अच्छे से सोना और फिर ही एग्जाम में जाना. गो टू स्लीप एट 9 PM और 8 PM, बट जस्ट हैव अ गुड स्लीप. आज जितना जानना है जान लो, पर कल प्लीज अच्छे से सोना. ठीक है? ऑल द वेरी बेस्ट. छोड़ दो सबको पीछे छोड़ दो. चलो बाय बाय.
Thank you, sir. Thank you, sir.
Thank you सर.